Section 8.5. Testing reactive applications with Spring, Reactor, and Testcontainers. When an application depends on a service downstream, you should test the interaction against the API specification of the latter. In this section, you'll first try the book client class against a mock web server acting as the catalog service to ensure the correctness of the client. Then you'll test the data persistence layer with slice tests using the data R2DBC test annotation and test containers, much as you did in Chapter 5 with data JDBC test. Finally, you'll write slice tests for the web layer using the web flux test annotation, which works in the same way as web MVC test, but for reactive applications. You already have the necessary dependencies on the Spring Boot test libraries and test containers. What is missing is a dependency on com.squareup.ok HTTP3 mock web server, which will provide utilities to run a mock web server. Open the build.gradle file of the order service project and add the missing dependency.
Listing 8.27. Adding test dependency for OK HTTP mock web server.
Let's start by testing the book client class. Section 8.5.1. Testing REST clients with a mock web server. The OK HTTP project provides a mock web server that you can use to test HTTP-based request-response interactions with a service downstream. Book client returns a mono of book object, so you can use the convenient utilities provided by Project Reactor for testing reactive applications. The step verifier object lets you process reactive streams and write assertions in steps through a Fluent API. First, let's set up the mock web server and configure web client to use it in a new book client tests class.
Listing 8.28. Preparing the test setup with a mock web server.
Next, in the book client test class, you can define some test cases to validate the client's functionality in order service.
Listing 8.29. Testing the interaction with the catalog service application.
Let's run the tests and ensure they succeed. Open a terminal window, navigate to the root folder of your order service project, and run the following command.
See this code.
Note: when using mocks, there might be situations where the test results depend on the order in which test cases are executed, which tend to be the same on the same operating system. To prevent unwanted execution dependencies, you can annotate the test class with test method order, methodorderer.random.class, to ensure that a pseudo-random order is used at each execution. After testing the REST client part, you can move on and verify the data persistence layer for order service. Section 8.5.2. Testing data persistence with data R2DBC test and test containers. As you might recall from the previous chapters, Spring Boot allows you to run integration tests by loading only the Spring components used by a specific application slice. For the REST API, you will create tests for the WebFlux slice. Here I'll show you how to write tests for the R2DBC slice using the data R2DBC test annotation. The approach is the same you used in Chapter 5 for testing the data layer in catalog service, but there are two main differences. First, you will use the step verifier utility to test the order repository behavior reactively. Second, you will define a PostgreSQL test container instance explicitly. For the catalog service application, we relied on the test container auto configuration. In this case, we'll define a test container in the test class and mark it as container. Then the test container's annotation on the class will activate the automatic startup and cleanup of the test container. Finally, we'll use the dynamic properties annotation provided by Spring Boot to pass the test database's credentials and URL to the application. This approach of defining test containers and overwriting properties is generic and can be applied to other scenarios. Now, on to the code. Create an order repository R2DBC tests class and implement auto tests to verify the data persistence layer of the application.
Listing 8.30. Integration tests for the data R2DBC slice.
Since those slice tests are based on test containers, ensure the Docker engine is running in your local environment. Then run the tests.
See this code?
In the next section, you'll write tests for the web slice. Section 8.5.3. Testing REST controllers with web flux test. The WebFlux slice can be tested similarly to how you tested the MVC layer in Chapter 3 and using the same web test client utility you used for the integration tests. It's an enhanced version of the standard web client object, containing extra features to simplify tests. Create an order controller WebFlux tests class and annotate it with WebFlux test of order controller.class to collect the slice tests for order controller. As you learned in Chapter 3, you can use the mock-bean Spring annotation to mock the order service class and have Spring add it to the Spring context used in the test. That's what makes it injectable.
Listing 8.31. Integration tests for the WebFlux slice.
Next, run the slice tests for the web layer to ensure they pass.
See this code?
Great job! You successfully built and tested a reactive application, maximizing scalability, resilience, and cost-effectiveness. In the source code accompanying the book, you can find more test examples, including full integration tests using the Spring Boot test annotation and slice tests for the JSON layer using JSON test, as you learned in Chapter 3. Polar Labs. Feel free to apply what you learned in the previous chapters and prepare the order service application for deployment. 1. Add Spring Cloud Config client to order service to make it fetch configuration data from config service. 2. Configure the cloud-native build packs integration, containerize the application, and define the commit stage of the deployment pipeline. 3. Write the deployment and service manifests for deploying order service to a Kubernetes cluster. 4. Configure Tilt to automate the order service deployment to your local Kubernetes cluster, initialized with Minikube. You can refer to the Chapter 08/08 end folder in the code repository accompanying the book to check the final result. See this link. You can deploy the backing services from the manifests available in the Chapter 08/08 end/polar deployment/Kubernetes/platform/development folder with kubectl apply-f services. The next chapter will continue our discussion of resilience and introduce more patterns like circuit breakers and rate limiters using Spring Cloud Gateway, Spring Cloud Circuit Breaker, and Resilience 4J.